In the roller coaster speed ramp lab, we're going to find the relationship between distance, time, and speed. We'll use the K'NEX roller coaster kit set up with 10 segments, which is exactly 2 meters, and a system of photo gates, which will actually help us record a more accurate time. Now, while the photo gates are not exactly 2 meters apart, it's okay, we'll fudge the numbers this time. We will keep the distance equal every single time. As you watch here, when the cart goes through the first photo gate, it'll start the timer. And when it goes through the photo gate at the end, it will stop the timer. This gives us an incredibly accurate reading of the time that it takes the cart to go down the ramp. With this configuration, it took exactly 2.035 seconds to get to the end of the ramp. We can do this again and show that it's pretty accurate and pretty consistent. If we do it a second time, we should come up with a similar, if not the exact, same amount. 2.14. Tenth of a second difference. It's pretty accurate. For this reason, since we're using this setup, we're not going to take an average of multiple recordings. We'll just do it once each. But if you were doing this without the photo gates, it would be a good idea to take multiple readings and find the average. That way, any inconsistencies in the track, in the friction of the roller coaster, or in the angle that you've got it, don't mess up your readings, and you get a more accurate picture of what's happening. Okay, so what we're going to do is we're going to lower this down to 1 book, start with 1 or 2 books to begin with, and build it up to get 5 different sets. We're going to record the time each time it goes down. The distance is going to be 2 meters every time. So you can go ahead and write down that in your chart, 2 meters for every recording. To start with, we'll do 1 book height. It is 1 book only, even though there's 2 here. The board on this end gives it just 1 book height to begin with. So we're going to go with 1 book height. We're going to record the time that it takes to go down the full 2 meters, and we'll record that in time trial 1. Remember that each time our distance is going to stay 2. And we'll record the time for each one. Since we're using the photo gate, again, we're only going to record 1 time trial, and we'll graph that data. If you were recording this by hand with a stopwatch or a stopwatch app, human error in starting and stopping the stopwatch is a problem. So we need to take multiple recordings and average them to get a more accurate reading. Since we're doing this digitally with the photo gates, we don't need to do that. Okay, without further ado, here is 1 book height. With a time of 4.18. We'll raise the photo gate, put another book in, and do it again. Are you ready? A little bit quicker that time. 2.999. Let's go ahead and round that up to 3. Again, we'll raise it up by 1 book. All right, now we're at 3 book height. 2.3. Should begin to notice a trend. As we raise the height of the ramp, the car's getting a little faster, which makes sense. Notice we keep our distance exactly the same every time. And now we're ready for 4 books. .00. We'll go ahead and round that up to 2.01. All right, let's do 5 books, and then we'll be done for the data collection portion. This is the only thing textbooks are good for, in my opinion, especially in a science class. All right, without further ado, 5 books. 1.72. Now that we have our data collected, we can move on to the next part of the lab, which is graphing this data. Once we've answered the questions in between the data collection and the graphing, we can start to plot our data. Now we have 5 points, each for different height, but you'll notice that the graph is labeled with the y-axis as distance already divided for you, 0 to 2 meters. And then the x-axis rather, x-axis is time in seconds. It didn't give us the numbers, so I had to split it up evenly enough that we can get our highest time value, which was 4.8. So I divided that up into 5 seconds and marked every half between them to help me gauge where the dots are going to go. Now you're actually going to graph this as 5 separate lines. So you'll do 5 points. Every one of them starts at 0, 0, okay? Because at 0 distance, the car had gone 0 seconds, okay? No time had elapsed before we start. Our second point for every line will be the distance and time. Distance is y and time is x. So we'll graph 4.8, 2 for our first point. 4.8 will be right around here next to 5. It's not got to be perfect, but we'll label it just for clarity, 4.8. I'm going to use different colors, hopefully I have 5 that'll show up, to plot each point, and then draw the lines to connect them. Our next line will end at 3, 2. 3. 2. 3 seconds at 2 meters. Our next line after that is 2.32. Okay. And our next line after that is 2, 4. I'm sorry, 2, 2. See, you got to make sure you're reading the right numbers. Every distance is the same. 2 seconds for 2 meters. And lastly, we have 1.72. So let's put that on there as well. Let's do orange. 1.72 there. Now what we need to do is connect these lines to their origin. Remember, we started at 0, 0 every time. I'm going to try to do this as straight as possible on the board here. Oops.
There we are. Next is 2 books. So this is 1 book. This is 2 books.
Now it should be pretty obvious that as we increased the height of the ramp, the time to complete the 2 meter distance was less each time. And the roller coaster moved faster as we raised it up. What we need to do next is find the slope of each line. The slope, if you remember from your introductory algebra last year, is the change in y over the change in x. And we don't have to use the graph to do this. We know what the change in y every time is. It's 2 meters. And the change in x each time is the time that we recorded. So the slope of the line for one book is going to be 4.8 . No, I'm sorry. The slope of the line for one book is going to be 2, the change in y, divided by 4.8, the change in x. That value, 2 divided by 4.8, is 0.416666. So we're going to round it to 0.42. For questions 15 through 18, I don't remember what it is, find the slope of each line. 1 book, 2 book, 3 book, and so on. You'll see that the slope is going to get larger. So for the second one, it's going to be 2 divided by 3. Which is 0.66 repeating. Okay, that's a larger number than 0.42. If you do this for all of them, the steepest slope, the highest number, is going to be 5 books. Using what we figured out based on our experimental data, you'll see that the slope of the line is directly related to how fast the car was going. Now, if we're measuring speed in meters per second, the units actually give you a hint to the formula for speed. If we measure our speed in meters per second, meters divided by seconds, what are we actually doing? Meters is a measure of distance. And seconds is a measure of time. When we do the change in y over the change in x, we're taking the distance and dividing the time. If the slope of the line is directly related to how fast the vehicle is moving, then the slope of the line is speed. So distance divided by time equals speed. And the formula is hidden inside the units that we use for speed. Speed is given by miles per hour, distance over time. Meters per second, again, distance over time. This happens a lot in physics. The units that you use will give you the formula for what you're looking for. Speed is distance over time.